Alright, let's do some problems from Chapter 7. A bowling ball has a mass of 6 kilograms and a speed of 1.5 meters per second. A baseball has a mass of 0.12 kilograms and a speed of 40 meters per second. Which ball has the larger momentum? Well, momentum is the mass times the velocity. So let's do the bowling ball. And we got to look at the baseball. Okay. The bowling ball has a mass of 6 kilograms and a velocity. No, they don't give us direction, but we can assume they're both going, to the right or whatever. It's not going to play a role in our problem solving here. And the momentum we don't know. Baseball has a mass of 0.12 kilograms and a velocity of 40 meters per second. Momentum, we don't know. So what you need to do is just use that equation. Use this equation, solve for the momentum of the bowling ball, solve for the momentum of the baseball, and whichever one's higher is your answer. Okay, let's try another one from Chapter 7. A rocket ship at rest in space gives a short blast of its engine, firing 50 kilograms of exhaust gas out the back end with an average velocity of 400 meters per second. What is the change in momentum of the rocket during this blast? So we're looking for change in momentum. So we have, let me draw this out. We have a rocket ship here. Okay, so it's going to shoot some gas. What color we're going to make gas here? Let's make the gas green. I don't know. So it's going to shoot out some gas. That's 50 kilograms of gas that's shooting out. It's blasting out. And this has a velocity of 400 meters per second. What is the change in momentum of the rocket during the blast? So if we have all that momentum going this way, it has to be pushing off of the rocket. So the rocket's pushing it that way, it's going to push back. So the rocket's change in momentum will equal the momentum of this gas. Okay, if that makes sense. This gas is getting a speed and it has mass, so that means it's going to affect the rocket. And so the rocket's it's pushing the gas, so the gas is going to push back on the rocket. That's how rockets go. So let's solve for this delta P. Let's solve for the P of the gas. That's going to equal the mass times the velocity. I wrote a different equation down there. So really you just got to plug in 50 kilograms times 400 meters per second. And that will get you the momentum of the gas, and the momentum of the gas is the change in momentum for the rocket.